So welcome to Intro to Azure Synapse. We're going to be talking about pools, machine learning, and a whole bunch of other stuff that you can, of course, do with Synapse. So a little bit about me. My name is Ginger Grant. I am an MVP. I'm also a Microsoft certified trainer. I've got a couple certs, and I'm also a past local group leader. I run the Arizona Data Platform Users Group, and if you want to get a hold of me, best place is on Twitter because I waste way too much time on Twitter. Okay, without further ado, let's talk about Synapse. So what is Synapse? Well, first thing it was a new version of SQL Data Warehouse. When Microsoft first announced that Synapse was a thing, they said it's the replacement for SQL Data Warehouse. And they made this announcement almost a year ago now at Ignite in 2019. Well, it's a whole lot more than SQL DW, although that part is true. They have since added an entirely additional component with the Synapse Studio, which will allow you to do querying of flat files, orchestration, and machine learning. So it's a whole lot more than SQL DW, although it is still SQL DW. Great naming thing. It's really hard to tell it apart. Is it another place to do ADF, Azure Data Factory? Well, in a word, yes. The ability to create ETL components is, of course, very important when you are creating solutions. So naturally, they include it inside of Synapse. Now, they didn't rewrite the whole ADF library. They ported it over. So if you are interested in, if you know all about ADF, congratulations, you now know orchestration in Synapse. It is that easy. It's a Spark implementation. So why should Databricks have all the fun? Microsoft also implemented a version of Spark with notebooks within Synapse. It is the same Spark implementation, open source Spark implementation that you see other places. It has all the Spark components, which we're going to be talking about as well. And it is a place where you can write SQL against blob storage. This is kind of a really cool functionality, the ability to do analysis on flat files. And lastly, Synapse is a word people say differently in different countries. I'm going with the American version, naturally, but hey, Microsoft uses the same one, so I figure I'm in good company. All right, a little bit more about Synapse, what we're going to be talking about today. So we're going to go over all the stuff that I just mentioned. We'll take a look at the pools, we'll look at the Synapse Workspace, and how you can configure that. And just for fun, we'll toss in a little bit of machine learning. If I have time, I'll also show you how you can fully integrate Power BI into Synapse as well, which is kind of a fun thing to do. You can completely bring Power BI into the Synapse environment. In addition, with Power BI's ability to connect to Data Lake Gen 2, the fundamental component of Synapse, you can, of course, create data just for the ability of reading it into Power BI from Synapse. So you've got a lot of options here. It's really a big environment. I know on Twitter a couple months ago, someone said, hey, I'm thinking about getting into Synapse, so I should know all about everything to do with data warehousing, right? And I'm like, no, not really. Because the fundamental component of Synapse is an Azure Data Lake. You need to create an Azure Data Lake Gen 2 or associate it with an existing Azure Data Lake Gen 2. And there are different kinds of pools, and the pools represent the different kinds of architecture within Power BI, within Synapse. So what is Synapse? It is both relational data. It handles the entire component for SQL DW. SQL DW is part of Synapse. So if you have a very large database and you want to create a data warehouse in the cloud, this is where you do it. You can do that within SQL pools. But let's say that you also have a whole bunch of call center data. You record all the calls that people make, and you want to analyze that data too. You can also do that within Synapse because it handles both semi-structured and unstructured data. So if you have a whole bunch of IoT files that you're are keeping for, say, temperature in a manufacturing facility, you can dump all of those flat files into Azure Synapse, technically into a data lake, and then you will have the ability to query and investigate those as well. So it really handles a whole bunch of different use cases within Azure Synapse. This is an overall encompassing slide from Microsoft that really shows you everything that it can do. On the bottom component you'll see here is the Azure Data Lake storage. So you have to create an Azure Data Lake Gen 2 in order to use Synapse. It's its fundamental building block, as you were, which is why everything goes on top of it. The data integration and your querying will all be done on a Data Lake Gen 2. And you've got two ways of reading the data that you are storing in your data lake. You can put it into Spark, or you can do a SQL on-demand, soon to be renamed a SQL serverless pool, to analyze your data, keeping it the ability to have it in data lake storage, which provides you a very low-cost method for analyzing your data and storing your data and not costing you a lot of money. However, if you wish, you can also create a data warehouse on top of it. And then the thing I said about low cost kind of goes out the window, but it is completely independent of your data storage and your compute. We'll talk about that in a little bit. You have the ability to use many different languages with Azure Synapse. SQL, of course, and not just wimpy SQLite either. We're talking real T-SQL. It's somewhat limited, but pretty much it's T-SQL. You can also write Python, .NET. .NET is fully implemented as part of Spark, so you can definitely use .NET. Java, Scala, and R. Scala is one of the favorites of people who created Apache Spark. As a matter of fact, that's the language that most of your Apache Spark commands are written in. And of course R. I will say that there is some limitation on what you can do with R, because R is not fully supported in the notebooks that are within Synapse. And with all these languages, you can do a whole lot of different types of analysis, or you can do simple ETL. You know, pretty much what you want to do is contained within the environment. So in order to create this, the first thing we're going to do is we're going to create a Synapse Workspace, which allows you to control the access to your data. It's in your collaboration container. It can integrate with Power BI. It, of course, has its fundamental building block as Azure Data Lake Gen 2. Provide security so you have that control over it. You can create SQL pools, which was used for Azure DW, as well as part of the workspace creation, you get SQL on-demand pools. You also have the ability to use Spark and notebooks. Oh, by the way, one thing that I do want to bring this up is this is still a preview application. And what this means is there's a couple of things that don't work right. I noticed recently I was having problems deleting things out of orchestration. Don't know why, but again, that was fixed later on, so I'm not going to complain about it. But some people are hesitant about putting code into production if it is not in general release. And so I just do want to make that clear that it is not in general release as of now. Maybe in Ignite, I don't know. Okay, so what do you get when you create a Synapse instance? Well, you're going to be doing all of your work within this Synapse workspace. It's called Synapse Studio, excuse me. And in Synapse, you have the ability to import your data. That's where you're doing orchestration. You can explore, do some analysis of your data, analyze your data with Spark, or you can visualize it with Power BI. So enough talk. Let's actually take a look at creating a Synapse workspace. So I'm going to go into Portal. But I'm going to go ahead and create a new one. I'm going to call it Cooking Show Style because I'm going to show you how to do it. and then I will flip to one of my existing Synapse workspaces, because who wants to wait 10 minutes just to see the thing load? Nobody. So I'm going to go ahead and create a resource. And of course I want to create Synapse. And notice it does say preview. Now these are the options that you have. The reason that Synapse Analytics, former DW, is in its own separate space is because that portion of the product is GA. So if you want to put up a SQL DW in now, it's part of Synapse, and naturally, since it was a minor modification to that existing product, it is, of course, in GA. Matillion ETL allows you to use a different ETL package. They say it's easier, it's third party, to be able to get into it. And Time Extender is designed for doing analysis of SQL DW and data lake information. For private hubs, this is for those people who have dedicated connections to Azure, and that's what this is for. So if you have that, then you will have the ability to use a private link, but naturally I don't, so we're just going to go with Workspace. This Workspace preview, there is no charge for actually creating it. Using it, well, that's another story. But creating it isn't going to cost you. So you can go ahead and feel free to do this part and not worry about any Azure spend whatsoever. So I am going to go ahead and hit the Create button. And you can either use a new resource group, create a new one, or use an existing one. I'm going to create a new one. So I'm just going to call this Synapse and Workspace name. This is the name of my Synapse workspace. And that's only be lowercase. Now, one thing to remember, since this is not yet GA, is you are limited in your regions. For those people who were talking earlier, this means that if you are in the UK, say, you've got UK South. The reason that the list is kind of important, only one in Australia, is that if you want to fully integrate Power BI with Azure Data Lake Gen 2, you will have to have it in your data lake in the same place as your Power BI workspace. To do integration within Synapse, it can be in any location, but if you want to integrate a Azure Data Lake Gen 2 with Power BI, it does have to be in the same physical location as your tenant. So keep that in mind when you are figuring out where you want to create your Synapse workspace, because generally speaking, that's where you are going to want to have your data lake as well. Another thing too, I've noticed in recent times, there are issues with being able to have all resources available in a data center as well. So I don't think we're going to see that today, but I can tell you that I have seen that before. Now, I told you that the data lake storage is, of course, fundamental to creating a Synapse workspace. So you can pick an existing one if you want to. If you've got one that's got tons of data in it already, feel free to go ahead and use that. But if you don't have one you want to use, you will need to create a new one. So I am going to create a new one. So I'm just going to call this BCRG Synapse Data Lake. And again, with a lowercase. Okay, file system name. What the heck does this mean? Well, the reason that you have to use data lake is because you are using the hierarchical file structure. So you always have to create a root directory for your hierarchical file structure that you're creating. I'm pretty uncreative, so I always call it root. So this is, of course, a starting point for my hierarchy. If I don't assign myself the storage blob data contributor role, I'm going to have to just go into RBAC and do it. So I'll save myself some time and put it here. You're also probably going to want to make yourself the owner as well, and assign others to it who need to do work with the data lake. Okay, so moving on to the next page. Notice nothing in here about enterprise. For networking, now this admin username and password is exactly what it says, SQL administrator credentials. So I know many people who create Synapse and don't do a thing with SQL DW. They don't care. That's not what they're using Synapse for. They want to do it for playing around with Spark. But if you are going to create a SQL DW inside of Synapse, this is where you're going to need to create your username and password. If you decide to do this later, perfectly fine. You don't have to do it right now. I'm likely to forget, so I'm just going to go ahead and enter a password now. I can always change this later on. For manage identity, this allows you to see if you can have the Workspace system control the permissions to MySQL pools. And if I want to allow pipelines, generally speaking, I leave this default on. I don't generally use a managed virtual network, so I leave this one unchecked. And I do want to allow connections from all IP addresses because that's the kind of security I have in my environment. But if in your environment you whitelist a given set of users, you might want to turn that off. Because that means that you are going to, if you have this on, then you don't have to go in and add each user IP to the list of approved ones, which is why I leave this checked. I never enter tags. I know you're supposed to. And then summary, which is basically going to show me everything that I picked. Now, what I am charged for is I am charged for, you're like, hey, you lied to me. You said you wouldn't get charged for this. What I will be charged for is using my SQL on-demand pool. So there are 3 different kinds of pools in Synapse. We're going to take a look at those 3 kinds of pools. And the one of them, the SQL on-demand pool, is created when you create your Synapse workspace. Now, creating it doesn't cost you, but using it does. So, and this is automatically created for you. You do not have the ability to change the compute on this, but and it is going to be created as part of this. So this is, again, showing all of the things that I selected. So if I say next, I can download a template for automation, or I can just from here go ahead and say create. Now, if I click on create, in a good 10 minutes, I'll get this. And this, again, is the cooking school version because we'll just pretend I already did this. All right, so if I had clicked create, I would be put in an environment like this. This is my Synapse workspace. This is where I have see all the things that I have generated. Now, this is sort of cheating because I do have this pool created already. This is, if you just start out, you would not have these 2 pools. But for interest of demos, I created them earlier. But I will go through how to create those. But I will automatically get my SQL on-demand pool. And with my SQL on-demand pool, I can do queries for flat files. Probably the first thing that you're going to want to do once you've got this created is you are going to want to go into access control here in RBAC and add yourself to the owner role assignment. So if I if I search, I'm just going to view my access and see that I am owner and contributor already. If I wasn't owner and contributor already, I would go ahead and make sure that this was added. So, and I'm also a classic administrator. So having contributor rights are automatically granted to you when you create this Synapse workspace, but you're going to want to make yourself owner as well. Just a little tip there. Okay, so back to the overview. So this is also, let's take a look at some information regarding our pools. So I'm going to go ahead and click on my SQL pool. And you can see that I have two pools. I've got my SQL on-demand pool. That status is NA. What does that mean? Well, not applicable. And the reason it's not applicable is that is always running. There's no need to turn it off because you are charged when you're using it. Not using it, don't get charged. Then there is a SQL pool. The SQL pool is charged every single minute that it's running, which is why mine is presently paused. This is where you would create your data warehouse. All of the rules that you have heard about, if not implemented yourself, when it comes to SQL DW, apply to the SQL pools. The SQL pools, you're charged for every single minute that it's running. So if you're not using it, you're going to want to go ahead and stop it. Let's go ahead and take a look at creating a SQL pool. So I'm going to go ahead and say new. And I'm going to enter my pool name, and I'm just going to call this guy test because I'm not going to save it again because I'm so lazy that I don't want to add another one. Because again, this takes about 10 minutes, and so who wants to waste that kind of time? So this shows you the cost per hour. So you can go all the way left and right on this slider. One thing that is nice about how Microsoft is created SQL pools compared to how Azure DW used to be created is that you can change your mind at any time. So let's say that I've got a data warehouse and it's running on a SQL pool and I think it's really slow. I can create a new SQL pool and then assign my new workspace to assign the database to use that pool instead. So because my data is separate from compute, I can give it a bigger computer if I wanted to. So once I create this, again, you'll see your performance levels here. Additional settings, use existing data, or because you can use it from a backup, and then you can change your correlation. Notice there's nothing in here about automatically turning anything off because there's no ability to automatically turn anything off. So, just keep this in mind when you are creating this and when you are done. If I went ahead and said review and create, I'll go ahead and do that. Shows me my estimated cost for the hour. Go ahead and click on create. Go back into my Synapse workspace and I get this pool. So I do not have TE configured, but I do have Geo Backup enabled. So, and this pool is paused, and I would need to start it up again when I'm going to use it, which I will do here in a later demo. The other pool that I have the ability to create is I have the ability to create a Spark pool. So let's take a look at Spark pools. So I'm going to go ahead and click on New. And this is where I can enter my name after my Spark pool. And give it a unique name. And I need to give it a node size. So I've got small, medium, and large. Kind of reminds me of a database that I know of. Anyway, and you can enable auto scale, or which is enabled by default. Now what this means is that your cost is variable because if you need more compute, it'll be assigned to you. 3 is the minimum number of nodes that you can use in your cluster. So if you don't want that kind of variability, you would just turn it off, and then you can see you can just scale it down to 3. So, and this of course tells me about the that I need to be notified if I went ahead and created this. So this is how I would create my Spark pool, and when I'm done, okay, it'll look like this. And one thing that Spark pool had is in its capability as well is the ability to auto pause. This is going to auto pause after 15 minutes. It does take about 2 or 3 minutes to start up again, which is kind of annoying if you are waiting for it, but it beats paying for it all the time. So this would be my Spark pool. Now let's take a look at the environment as a whole. So after I've got my pools created, got my security set up, generally speaking, what I'm going to be doing is I'm going to be going into the Synapse Studio. Man, I guess I made it mad. Kim? Okay, so I'm going to go ahead and launch Synapse Studio. Now, for those of us who unfortunately do have a lot of different Azure portal accesses, you can confuse the studio with logging in and out of a whole bunch of different accounts. You may need to periodically go in and clear your cache if you find that Synapse won't load, because it sometimes gets confused with some of your cached credentials. So if you can't get into it, yeah, that's probably why. So delete your cache and try again. So these are the different areas that are created from within Synapse. I'm going to go ahead and click on Ingest here first. And for ingest, this is my Azure Data Factory area. This is the wizard section of it, where I could connect to a given source, run a connection, and deploy it. So I have the ability to copy data, and I can go ahead and say where I want it, what connection that I want, where I'm going to want it to go. And one thing that's kind of cool that has been added recently is, I just saw this today. These are all of the different built-in connectors that you could connect to. And I saw it, and if you are familiar with ADF, you'll see this too. Interestingly enough, I just saw that Excel was out, but I'm not seeing it here. I saw this documentation that was released yesterday. So again, this is your standard orchestration, also known as ADF. It shares the same code. If you look at the documentation now, you will see that it says that it works for both ADF and Azure Synapse. And this is the other area that orchestration lives in. So if I had orchestrations that don't, this would be where it would live. So the next option you have is the ability to explore with your data. So you can use this little wizard, but what it's going to do is it's going to take you to your data. So I have my paused database here where I've got some external and internal tables, which I can't see because it's not running. And then I have my linked Azure Data Lake storage. And from within here, I can take a look at the data that I happen to have contained within it. And you see here that I've got some data warehousing data. And if I want to take a look at it, I can just right-click, unselect top 100 rows. So this is automatically going to create the commands for me. I didn't have to remember what the heck I had to do to be able to access data from a CSV. The one thing that you are going to have to do is you are going to have to type a with statement and put in all of your column names because it doesn't know from column names. So every single time you do this, you are going to have to define what your headings are. But if you can, of course, persist this once you have it created so you don't have to do this every single time. There are a number of different file formats that you can query. The most popular being Synapse. Within Synapse are Parquet and CSV. So, but yeah, again, and I have the ability to query this by just right-clicking. And then I can go ahead and query any of my data that I've got available to me. So kind of nice, gives you the ability to take a look at it. It also has some charts. Oh, it's not going to work very well as a chart. Let's get some better data to work as a chart. It's very similar to what you would see in, here I've got some Parquet files that I have created, so I can query these as well. And yeah, this is supposed to be Delta. I don't know, I think it's up. I wanted to show you some better visualizations, and I'm not going to really come up with some, so I'll just do it from with here and here. And show you the charting functionality that's available. So I can click on chart and it shows me that I've got my line and categories. Of course, this has a whole lot more meaning when I have defined all of my columns. But you can, create lines, create categories, make this a bar chart. It's pretty much using the same kinds of visualizations that you are able to do within Azure Data Studio. So some more kinds of stuff. So going back to the analysis, you also have the ability to analyze your data using Spark. So to do that, you would go into creating your notebooks. And I've got some notebooks here. This one is where I've got some Delta Lake code that I've been working on, looking to how I can write Python code using Delta Lake within Azure Synapse. So just a little kind of review of the different elements that you can do with this. So kind of a neat concept. The other icons that are available here are monitor. And I don't have anything going on at this point in time, but it does show the last 24 hours. And also in manage, you can see your pools here, your link services. So I'm linked to my default storage, my orchestration triggers, so anything that I'm doing to kick them off, and runtimes. I also can show my access control. This is kind of doing something similar to what Databricks has when it comes to having groups of users having access to Synapse. So with that, are there any questions about this yet in particular?
Would there be a performance difference between the built-in Spark in Synapse and Databricks?
So the performance on both Databricks and in Synapse is, of course, dependent on how big of a resource that you have assigned to it. So you could make it go faster by assigning the same size workspace. There are some performance features that Databricks has baked into their version of Spark. Spark is open source, but Databricks runs a slightly enhanced version. One of the things that you see with their version is their version of, say, Delta Lakes is a little bit faster. And they do have other things that they tout as being faster because they've written it, and so they're running a proprietary version of Spark. So, but the Spark that Microsoft is using is the open source version.
My question is that there seems to be at least 3 ways in Azure to do the same thing. So what are the use cases for using Synapse versus Databricks versus HD Insight? And I think from my perspective, I understood the cost was the driver, and I think if you've got a long-running load, then HD Insight might be better cost-wise, but I've never been able to find any supporting documentation to show that.
So in terms of, I'll address the one that I hear the most common first, the difference between Databricks and Synapse. Why should you use Databricks versus Synapse? Well, the big reason is one of them is GA and one of them isn't. So there's a lot of people who are hesitant about running code that is not been released yet. And the Spark components of Synapse are not GA, they're still in preview. So that's the biggest reason. And because it's still in preview, there are a couple of things that have not been added, but I am assuming are going to be a part of Synapse when it's released. And the big thing is DevOps integration, which is not available presently in Azure Synapse. In terms of the difference between why you would want to use Databricks versus Synapse. Those are some reasons. The other reason that you might want to consider is that because some of the stuff that Databricks is doing with Spark is proprietary. They have implemented a couple of things that only work in their environment, specifically around Delta Lake. Their Delta Lake is not the same as open source Delta Lake. So if you've got a lot of code that works in Databricks out of the box, it's not going to work straight out of the box in Synapse because they're using a proprietary version. In terms of HD Insight, if it's cheaper, that's a very good question, and I do not know the answer for that. I know that the interface isn't as nice, so I realize it's kind of a lame reason, but I'm not as familiar with the HD Insight component of it. I will say that I think that with HD Insight, you are limited using HD Insight with Spark. So if you're good with that, that's great. You know, you want everything in Parquet, but it's a little bit less flexibility than doing it within Synapse. So it depends on the kind of work that you're doing, whether or not you want to select that over this.
Cool. Okay. Yeah, I mean, the only thing I know about HD Insight is that it's always running, so you can't pause it like the others. But finding cost comparisons has just been impossible for me.
Oh, yeah.
Cool.
Good luck.
The former data warehouse version of Synapse would be in general availability right now. How does that apply to the data warehousing, the SQL engine parts of the preview? Would they be compatible, or would it be major changes so you have to rewrite even the SQL engine code?
So when Microsoft created the Synapse SQL DW part of it, what's called SQL pools, they made it as a migration pattern. So from the code perspective on from SQL DW to Synapse, which again is GA, that's considered an upgrade. So it's got a clean upgrade path. No rewriting needs to be written. The reason why you want to move to Synapse from SQL DW specifically, it is they have improved some of the underlying performance architecture, which makes it go faster.
Okay,
so
good.
There are some definite benefits that have been added into the engine that were not available in the previous version.
Perfect. Thanks.
All right, so I'm done with the demos right now. I'm going to talk a little bit more and then go back doing more demos. So I wanted to do an in-depth dive on Apache Spark pools, since that's a lot of what people are interested in playing with Synapse. So it uses the same Spark clusters that are used in Databricks, almost, because again, they use a proprietary version. And Apache Spark is part of the open source Hadoop framework in memory processing. So Spark was originally created out of Berkeley in 2010. It was a class project to figure out, to win $1 million Netflix prize for coming up with a better algorithm. And so what they did is they figured out how to load HDFS data into memory very, very efficiently. So when you are using Spark, you are using HDFS. As a result, it does this high-level in-memory processing. What it does is it breaks up your data, and then it processes it very, very quickly, iteratively, all at the same time, and then puts the answers back together. And that's really what you're doing with Spark. Spark has really taken the entire development space by storm. I highly recommend that you use it because there's so many places that use it. One of the things that's interesting about Spark is if you're doing Spark, while it may seem that you're streaming the data, you're actually doing what's called micro batches. They do little bits of data that looks so small that you can barely tell. But Spark does handle streaming, machine learning, and graphics database. The version they contained within Azure Synapse is preloaded with Anaconda, and it integrates with JetBrains IntelliJ to create Spark Pool apps. So that is already included within the environment. If you want to create different Python libraries primarily, I work in Python so I think of it, but any kind of libraries where you want different libraries to be available to different applications, that is handled in your pool. So if you have, an older version that you have code that relies on for one code, and you have newer version, another version, you would need two pools for that, because that's how the libraries are maintained. That's where your virtual environments are maintained. It's a little bit more on Spark. So it's got these 4 components and core. So the core component is Spark SQL. As a matter of fact, I attended the Spark AI Summit virtually in June, and they said that over 90% of the API calls in Spark are for SQL. Now, it's not real SQL. It's a form of ANSI SQL. The reason that I say a form of ANSI SQL is that the version presently implemented within Synapse is Spark version 2.4. Whoops. Spark version 2.4 does not have full ANSI compatibility. When Synapse moves to Spark 3.0, then you'll get full ANSI commands. So that will allow you a lot more, functionality. But again, ANSI, not T-SQL. In addition to Spark SQL, you have Spark Streaming, allowing you to process data if it's streamed, the same as batch. It doesn't really care. Again, it's because it's doing micro batches, but it does handle streaming data or batch data in the same place. The other thing that Spark has is it's got its own version of machine learning. Now, while you do not have to use Spark components for doing machine learning, if you don't, then you can't scale them. So it was important for them to create a library that contained the common machine learning algorithms so that they would be able to process very quickly on top of Spark. And lastly, it contains a GraphX components, graph database, allowing to analyze data using nodes and relationships. Nodes is an entity like a person, and the relationship represents the relationship between the nodes. This kind of analysis is often done to analyze social media, email, or doing intelligence gathering to determine who knows who. So these 5 languages are supported in Spark. R is not supported in Synapse Studio Notebooks. So keep that in mind if you're a big R fan. Scala is what this icon is on .NET, because Microsoft made sure that .NET was fully Spark compliant. And Java, again, is not supported in Synapse Studio Notebooks, and a majority of things are done in Python. So Spark is not included in here because it's an integral part of the language. So you can do, it's kind of like a bonus language on top of those. So with Synapse Studio Notebooks, that can be used to analyze your data. You can use it to be part of an orchestrated pipeline. It supports the languages that I just mentioned. And it contains a toolbar for common formatting, which is nice if you don't have all of your markdown commands memorized. You can just do things, and it will, for bulleting and code snippets and stuff like that. Another thing that you can do with notebooks is exploratory data analysis. You can do those. There's 2 different kinds of ways you can use notebooks. You can use notebooks with Spark, or you can use notebooks how we showed you to you before, where you have your notebooks that are something that you would do to query SQL. Basically, everything's a notebook. So with Python, the libraries are installed in the Spark pool. This also includes the Microsoft Azure SDK for Python, and that's a set of libraries which allows you to work with Azure for management, runtime, or data. The PySpark version that is being used is 3.6. And when you are creating notebooks, you have the ability to go all in on one language, or you can switch back and forth using magic commands, which I'll show you, of course, in the demo. Parquet files. I definitely wanted to bring up Parquet files because everybody talks about Parquet files and nobody tells you why you want to use them. It's kind of like when you're using pie charts. No one tells you why they hate them. They just tell you they hate them. So the reason that Parquet files are so cool is that they store data in a columnar format, just like Power BI does, and like column store index on SQL Server. And this kind of column store index makes it very, very efficient because they can do compression. So as a matter of fact, Databricks has looked at some analysis on what kind of compression that you can get. And they're saying that if you modify your data from CSV to Parquet, you can reduce your data storage by 75%. And that actually is more than just which one processes it faster. If you decrease it by 75%, then that reduces your storage costs as well and your memory costs. So you have a lot of benefits for using Parquet files. It's not horribly hard to change your data to CSV files. If you just Google it, you can find yourself some Python code, and 5 lines later, you can change your CSV files to Python. And then people with Power BI can't read them. So you do want to look at using those when you're doing Spark. So with that, I'm going to go ahead and do a demo within machine learning doing Spark to show you some of the things that we can do with this. Okay. Going to a different workspace. I really should consolidate, but you know. Okay, so let's take a look at some of the notebooks I have here created for doing things with Python. So with Python, one of the things that you can do is you can use data lake. So here you can see that the data lake is a type of overlay that's put on top of blob storage files to allow them to act more like databases. So a couple of things you can do is you can create tables on top of a data lake, and you can enforce the schema. You also have the ability to create snapshots of your data, and when you have these snapshots created, you can roll the data back. So here what I'm doing is just make sure that I'm going to just create a random table, and this is the path that I've given it. And this is using PySpark and I have to start up my Spark engine because after 15 minutes it goes to sleep. I should have done that more quickly. There are better ways coming to organize your notebooks so that there isn't going to be such a giant mess of this, but this is the way it is now. Here is all the list of the Spark engines that I have. If I had multiple ones, I could definitely select them. While the Spark is starting, since I'm impatient, I'm going to take a look at looking at some other ways that you could use Python within Synapse. So here's what stuff I've done recently is that you can do a number of different visualizations, and I took a look at creating some of them here, so you can analyze your data and take a look at it. Here's just some stuff with Matplotlib. I could also do some pretty fancy bar charts to analyze my data, and are looking at analyzing my raw data, creating histograms, cumulative histograms, or even some kind of scatter charts for stack plots, or even the dreaded pie chart exploded naturally. You can do different things with different kinds of fills, and I can also do different subplots if I want to. So I've got a lot of different options that I have within Spark. All right, so now back to Delta Lake, now that it's running. Is it still starting? I was all happy because it was gray. If I go to manage, I can see that my SQL on demand is available. And I can look here, look back at manage, and I'm looking to see if the pool is available, and go ahead and hit refresh. And it's not showing the Apache Spark pool here. Refresh it. It's not showing me that it's running. But it will show me how I've got it configured. And you can see that it's enabled to have be idled after 15 minutes. This is the version of Apache Spark, the version of Python, Scala, Java, and .NET. So it shows you the name of my workspace, resource group, and any packages that I have created within this library. All right, and installing. Hopefully if I go back now, it will be running. Yes, all right, so I've created my table. And this is just putting some random information into my Delta Lake. And I wanted to do that so that I could see that how that information is logged. And then I want to just be able to read my data. And I'm just doing this so that I have data that I can show you how I can manipulate it with Delta. So this is just basically loading up some data so that I can make this happen. All right, so I've got just some random values here that I created. And I want to take these random numbers that I created and I want to go ahead and update them. So I'm going to go ahead and run this so that I can update my values. And the reason that I'm updating them is so that I can show you how I can look at the rollback data. So I overwrote the data and selected new random numbers. So now I went from this to this, so now I have two different versions. So then I can look at the data and see that the original is gone. If I wanted to read this log, which I'm not that bored. And then I can make a managed catalog table. And that means that I'm managing the what is being stored. Then, of course, what I can do is I can use Spark SQL to create an external table in my Delta Lake. And then I can show you the tables that are created. So now I've got just some tables that are created, and I've got two of them. So now I can do an update so that I can update and not overwrite if I don't want to make that happen. And I can also update every even value by adding 100 to it. Should I do that? And then I'm going to delete some values as well. So now I've updated my data, and then I'm going to delete all the even values, which means I'm going to have 3 values left. So then I can merge my data. So I got 2 tables. And the reason that I'm doing all of this to my tables is so that I can show you the history. People who aren't familiar with databases think this is time travel, and I'm not seeing it TARDIS. So I'm just thinking this is looking at logs, but it's kind of an interesting thing to be able to do. Come on. All right, so now it's showing me my addition, the fact that I've merged them together. So now I can take a look at the history that I've created by doing this kind of manipulation to my data. So you can see that I've got different versions of this created. So I've got 4 different versions of this data that's created, so that I can look at. And of course, these are 0, 1, 2, and 3. So I've modified my data, I'm looking around with it, and what that means is I've got 4 different versions of it. So what I can do is I can read whichever version I want to. I just have to put in the number. So I can go back here and look at the first version that was running. So whichever version that you want to be able to look at, so this is just showing top 20, I can go back and look at whatever snapshot of the data that I want to take a look at, which is really kind of cool. All right, so let's go ahead and do a last demo where I'm looking at predicting whether or not somebody is going to get a tip. So what I'm doing here is I'm doing some analysis of a large open source data set of taxis. And I'm going to go ahead and predict that by first loading some of my libraries that I'm going to need to use to run this particular module. Yeah. Spark is already running, so it shouldn't take so long. So what this is doing is I am going to be reading data just for a week because I don't want this to take all year. So I'm going to be reading data for May 2018, just for the first week. And I'm just going to be importing that into data set and using it into memory. So I'm going to actually sample that data too, just to decrease the amount of time that it's going to take because I have so much data when this runs. And I must not have, why is this taking so long to start it up? But hey, it beats it running all the time. So what I'm going to do after I get it running is then look at some analysis. I'm just going to look at a data frame, and I'm going to use a pandas data frame just for sample reasons. I will say that I'm just messing around here. You would never want to use any kinds of pandas in a production environment. And the reason why is pandas is not Spark, so it will not scale. Play around with it, do whatever you want to do with it, but if you're doing it for something that is going to be used in perpetuity, you're going to be wanting to use koalas, which is the pandas replacement in Spark. So they made koalas, again, a cute fuzzy animal because that's the only way they roll, to make sure that you can do that using the same code as pandas. Koalas came out last year, the same time that Delta Lake came out, and it was fully implemented in June and is part of the implementation. So okay, so I've got my data selected. I'm just going to scale down my data here a little bit. And now let's take a look at charting my data, which I'm doing because I'm cheating and doing it in pandas and it supports it better in my environment. Of course, this would run faster if I had much bigger Spark cores, but yeah, I'm cheap like that. That's what's really great, though, about everything that has been implemented within Synapse, because they made sure that the data was separate from the compute. Okay, so basically, a lot of people didn't tip. So the tip is like around, close to zero here. And then very few people gave $20. So basically, it's a whole lot of, like a couple of dollars tips here. So if we look, it's basically looking at by passengers. If they're lucky, they get $80. The amounts are generally hovering below $20 every single time. It's interesting, even if you have more passengers, the tip doesn't seem to go up. The tip is proportional to the fare, though. So the more you pay, the bigger the tip. And the way that percentages works, that really makes sense, doesn't it? So, all right, so now what I'm going to do now is I'm going to look and see if there's some outliers in the data, like, this person, maybe they just won the lottery or something. But if I'm analyzing data, I want to throw that guy out because he's going to screw up the averages. So, and I got a couple of wild-eyed averages way over here where the fare is really high, but I don't have a whole lot of data with fare is really high, so I won't be able to analyze that terribly well. So what I'm going to want to do is I'm going to want to filter out those outliers so that I am not going to analyze them in my analysis. So, and then I'm going to create derive my tables, doing a little bit of grouping to help its performance improve. So I'm going to look at the hour rather than the time, just looking at that, looking at the week, day, looking at drop-off time, minus date time, and with tip amounts, so just taking a look at the data. So then I'm going to be adding some new features, looking at the trip distance, pickup hour, weekday string, whether or not they tipped. So I'm creating, and then creating some classifications of my time, calling it night, AM rush, afternoon or PM rush, and creating these different bins to make that happen. So then I'm going to want to do logistic regression. And what I'm going to do is, again, I'm trying to find out whether or not somebody got a tip. So that means I have to convert any text to numbers because the logistic regression algorithm doesn't know how to do that. So the other thing that I'm going to do is something that's called one-hot encoding. And so with how one-hot encoding works is, let's say that you've got a column called fruit, and you have in your fruit column, you've got bananas, apples, and pears. And what you do with one-hot encoding is you flip that so that you have a column for apples, a column for bananas, and a column for pears, and whether or not you had values in that column would be 0 if you don't and 1 if you do. So that's what kind of thing I'm doing here with the one-hot encoding. So I'm going to be doing that with my data, just to format it a little bit differently to make it work better with my algorithm. And then I'm going to use that to create a final data frame that has both my groupings for my hours here and also my one-hot encoding for my weekday strings and my traffic time bins. So I'm going to have all this night tipped and rushed, just like 1 or 0, to see whether or not that data occurred in that time frame. So once I've got my final data developed, what I'm going to do is I'm going to split my data between test and training. And this is how I'm going to determine whether or not my algorithm is any good. So 70% of them are going to be trained. So I'm training the machine learning component to see whether or not I tipped or not. And then I'm going to compare that to the test sets to analyze reality versus training, because with training, I take out the results, so I don't know what the results are going to be. So I'm going to go ahead and run this. And that just splits my data sets and take very long. Now I'm going to train the model using logistic regression. So and tipped is my binary label column. So whether or not you are tipped is yes or no. So just want to know if you tipped. I'm not looking at how much of money you tipped, but I'm looking at the hour, if it's a weekday or not, the number of passengers, the trip time, did that in seconds, the distance, and the fare amount. So those are my elements that I am going to evaluate here. And I'm going to use that to create a model. And I'm going to save the model so that we can take a look at analyzing the results. So what I'm doing is 1 or 0, yes or no. And I'm going to evaluate this using area under the rock. ROC stands for receiver operator characteristic. And what you are doing in this kind of binary classification is trying to determine if you have data that is better than a coin toss. A coin toss is a straight line from one corner to the other, segmenting the graph into 2 triangles. And you want to be better than a coin toss, because if you're not better than a coin toss, then your algorithm is really not very useful, because you're trying to predict with accuracy, not just make lame predictions. So I'm going to go ahead and run this analysis. And then when it's done, it's going to print the percentage of area under the rock. So the higher the number, the better. Yeah, 100% is not realistic in the world we live in. That's kind of like playing a game of golf and you only hit the ball 18 times. Never happens. So, but we're trying to get it to be close and see how well we can train the algorithm to be able to guess based on the values what the results are going to be. So we're actually training it how to analyze data, looking for patterns within the data using the logistic regression algorithm. All right. The other reason it's good that we randomized our sample with this is that one thing that you have to worry about when you are training machine learning models is I'm not done when I run this. And the reason that I'm not done is because I could always do better maybe with a different algorithm. And that's a constant thing with machine learning. It's like, but this one could be better. And people spend, weeks and weeks and weeks on the same problem looking for the best solution that they could possibly come up with, which, doesn't always happen. So there are a number of different ways to pick the best algorithm. The way that I generally do it, because I've gotten lazy, is I use a tool that picks the best algorithm for me using AutoML is one. There are several other ones. I know Data Robot makes one as well to have use machine learning to pick the best machine learning algorithm. When this API is, of course, available within Synapse, I need to come up with a demo where I'm using that so that you can run through all the algorithms to know which one is best. Cameron. Okay, so there I got my result. My result is awesome. Area under the rock of 97%. So what I'm going to do is I'm going to take a look at plotting that. And when I do, it looks that I have a wonderful algorithm and I'm correctly able to guess the majority of the time whether or not somebody is going to tip using this algorithm. So all I need are these variables and I can determine whether or not someone has tipped or not. All right. In summary, what we did today is we took a look at Azure Synapse. We looked at data analysis. We looked at the different kinds of pools that are created. We took a look at Spark, and we did some machine learning. And with that, are there any questions? One thing that I would like to mention is this is obviously a very high-level overview of Azure Synapse, and if you would like to know more, I am doing a pre-con as part of Past Summit where we'll be doing a day-long in-depth dive into everything you can do with Synapse. So if you're interested and want to do more information, sign up at Past Summit 2020.
Excellent. Thank you very much for that, Ginger. I want to play around with Synapse now. I have a question about the storage, because at the beginning I know you created a new storage account and a new directory, but it looks like you can use an existing one, and from that it looks like you can potentially share an account across workspaces. My question is, if that is the case, is there ever really a good time to share a storage account?
So in answer to your question, yes, you can share storage accounts, and you may want to do that because you've already got a whole bunch of data created that you want to use. So, Synapse is relatively new. You may have been putting a ton of data into a data lake for years now, and why not use it? There's no reason that you have to create a new one if you don't need one. I will say that I am talking quite a bit on my pre-con about how you can organize data lakes, because I have seen a whole bunch of them be nothing but giant steaming piles because you can't find anything for. So that's always an issue.
Cool.
Yep, and I have a question here that I probably could answer myself. How could you control when or if the on-demand SQL pool is used? But I saw when you created the database, you chose to create the database on a pool. Wasn't that right?
So that's a really good point. So there's three kinds of pools. Two you create, one you don't. You create SQL pools and you create Spark pools. The on-demand or serverless pools, those are created with the Synapse Workspace. So you can't control the size of that. And the on-demand pools, those are used whenever you are doing queries on flat file data. So whenever you're doing that, it will cost you, but it costs you $5 US per terabyte. So it's not going to eat you alive, generally speaking. And there is no way to make those pools go faster or turn those pools off if you're talking about on-demand pools. Of course, if we're talking Spark pools or SQL pools, those you can make bigger, those you can turn off.
Cool.
Great. So next question is, obviously, if you turn on auto scale, we kind of understand that it will scale up as the load demands it. My interest really is, when does it scale down? Is there kind of anything publicized in terms of, how long it will take? That's
a really good question, but generally speaking, when you're talking about your pool, you're talking about a given workload. So I don't know how quick it is, because that's kind of black magic on my perspective, but it will scale down when you don't need it, when you're not doing anything. And in the development kind of workspace that I'm using, I do a lot of batches and then I'm done for a while. So it scales back down when the work has been completed. But it's looking at the usage and performance over time and determining when to scale down. So as far as I know, there's no great metrics on scaling. But of course, that's optional, and you can control both how much it scales and if you want to scale it all.
Perfect.
When you load data into this new Synapse thing, could you still use the regular ADF, or would you benefit from moving your ADF flows into the new environment?
So definitely you can still use ADF because you're talking about putting data into a data lake, and you don't have to use Synapse for that. But from what I've seen, there's a bit of a cost benefit from doing it from within Synapse. So, but you don't, there's no, yeah, it's a great reason everybody do it, because you're not getting additional feature and functionality for the same, it's the same code base. So it's up to you which you choose to do. I don't think it'd be worth the effort to convert it at this point, but there may be a use case at some point that may illustrate that, especially if more information comes out about pricing details, which I understand is a little bit presently more beneficial in Synapse.
Okay, thanks.
Excellent. You did touch upon earlier, I think you mentioned that there's not really much DevOps support for Synapse Analytics right now. One thing that I was interested in is regarding the ADF integration. Normal ADFs you can link to a repo. I was just wondering whether it's possible to do that with Synapse ADF.
It is my understanding that they hope to add DevOps capability to Synapse, but nothing like that exists at this point.
Okay.
So I understand that is definitely something that is a feature that is going to be a part of the eventual solution, but there's nothing like that now.
Yeah, no problems.
You said when you looked at the CSV file that it was Spark doing the read, and that you can read CSVs and Parquet files only. But could you choose that it's the SQL data warehouse part reading the files using Polybase?
So I misspoke, because you can do more than just CSV or Parquet. If you are using Polybase, that's not necessarily, you're using Polybase, that's not, it's you can use that as well. So, and that's just another way of using it, and you can use Polybase to read any kind of file that Polybase supports.
So it's using Polybase in the background, right?
Yes, yes, it is.
Yes.
Okay, great stuff. So I think you also touched upon this as well. They're also a great presentation as one answers all the questions before you ask them. But I'm going to ask it anyway. You touched upon the fact that, I forget what it was now, but using, it's pandas, wasn't it? You say koalas was the one to use for scaling. So that was really my question. Are there any other big pitfalls to consider when you're developing code of utilizing the full cluster?
Well, one thing that to keep in mind when you're writing code is you're writing it for Spark. And Spark was created to make it go fast. And so you have to use the Spark components to make that happen. So you need to be using the machine learning library components that are in ML Spark, and you need to be using, either koalas data frames, or native Spark data frames, and not pandas, because again, it has to be part of Spark to make it go fast. This is kind of an issue with some data scientists, because while there are a number of machine learning algorithms in MLlib, it's not all of them. So there are some instances that you can't use Spark because the algorithms that you want to use are not in Spark, and so it won't scale that well. They are working on adding more though. So.
Yeah. Thank you for
that. One question here is, can you import third-party Python libraries or even .NET functions?
Yes, absolutely. You have the ability to import any libraries or functions you choose to use, and they are stored in the individual pool. So if you decide that you want a bigger pool, you're going to have to move the libraries that you've added.
And they can connect to just about anything. So you can connect to Cosmos DB or write Gremlin queries with a Spark Graph API.
Yes. As a matter of fact, Cosmos DB is a big-time use case that Microsoft has invested pretty heavily in. It wasn't available originally, but they wanted to make sure that you can, of course, connect to it and use it within Synapse.
So is that's what's known as Synapse Link, is it then, Ginger?
Yes.
Okay, cool. Right, so final question. In Databricks, you can predefine tables through the GUI. I didn't see that it was possible in Synapse to do that. And kind of an extension to that question is when you've created your tables in code, how long would they persist for?
Well, the answer to can you do it is yes, and I'm sorry that I didn't include that in my demo. I will be smarter next time and make sure that I include the ability to persist, because yes, you can do that.
Okay.
So, and that's, I guess, the answer to the question, that yes, you can do that like you can in Databricks.
Okay. So you know when you run some code to create a table, does that just persist for the runtime session, or will that persist, ad infinitum?
Ad infinitum.
Oh, right,
Until you kill it.
Okay, fantastic. Well, I think that wraps up the questions. So that was a brilliant session, Ginger. I want to go away and play with Synapse now. Thank you very much for joining us tonight, Ginger. Really appreciate that, and hopefully we'll speak to you sometime soon.
Looking forward to that time.